Okay, great. I'm Dr. Halasa. I'm the founder of Chronic Disease Prevention and Management. And today we're going to talk about CDPMS protocols for cancer reversal, mechanism, and therapeutic use of ivermectin and mebendazole against cancer stem cells and fibrosis. As we know that oncologists, they are using chemotherapy, radiotherapy, immunotherapy to destroy the cancer, plus other things like CAR T cells and many other um, methods. And unfortunately, we only have 60% success of eradicating cancer. Less than that. We have actually 6% failure of eradicating cancer, especially when it comes into stage 2 and 3 and 4. Um, and that's the reason we need to know exactly why we fail. And as I said, we fail because those chemotherapy, radiotherapy, and immunotherapy and CAR T cells are very good in destroying differentiated cancer cells. But when it comes into cancer stem cells, those tools are not that effective because the cancer stem cells behave like normal cells and they have enough of antioxidant machinery that can neutralize those free radicals generated from those radiotherapy and chemotherapy. And they're very difficult also to be recognized by the immune system as well. And so that's the reason why they fail in eradication. Now, shrinking the cancer, we're very good in shrinking the cancer, but does not mean that we eradicate the cancer. And they shrink into, especially we're talking about solid cancer, into very hard tissue, fibrotic tissue, hidden inside them stem cells, and those fibrotic tissue form as a shield to protect those cancer stem cells. And those cancer stem cells are very resistant to chemotherapy, radiotherapy, even immunotherapy. And that's how the cancer is kind of hibernating, is retracting into that shrinked, dense tissue, how to penetrate drugs inside them. Radiotherapy, you have fibrosis, so all those fibrosis is it's like a shield is taking the hit, and those cancer stem cells, they have enough of antioxidants to neutralize the free radicals. So we really need to know how to break those shields. And in addition to that, when those chemotherapy, radiotherapy damage the mitochondria, then it will lead to aerobic glycolysis, right, of the cancer, relies on that. And that leads to acidosis, and acidosis leads to fibrosis and dedifferentiation of cancer cells into cancer stem cells. So it makes things worse in terms of that. But it's good that we're able to eliminate um, and shrink the cancer, especially the differentiated one, and shrink them down. But once they get into that dense tissue of cancer stem cells with fibrosis and as I said, the tumor microenvironment is in favor of the cancer, and also the acidosis is shifting the immune system to Tregs. So the Tregs will form also another shield that protects the cancer, makes the cancer immune tolerance. And so we need to come up with a strategy to destroy those shields and destroy those cancer stem cells. And I think that's the reason why the mainstream medicine failed, because they don't know how to tackle cancer stem cells and fibrosis and how to shift the immune system from Treg into Th1. Although they are doing it with cytotoxic T cells, although they're doing it with immunotherapy, still the immunotherapy, if they are giving it nakedly, it goes everywhere. So it may lead to autoimmune, which will drain the immune system and gives you the same problem, which the immune system, instead of attacking the cancer, they're attacking your self antigen and self tissue. And so that's the problem. So now we know the problems, and we know that the fibrosis squeeze the blood vessels, preventing the infiltration of the lymphocytes and the red blood cells. Doing that, then you cannot destroy the cancer, because in order to cause cancer, you need to have cytotoxic T cells and natural killer cells. You cannot kill the cancer with neutrophils. And that's why the cancer is very smart. They shift the immune system into Th17, because Th17 leads to neutrophils, and the neutrophils will not do anything to the cancer. and also to Th2, let's say antibodies. Antibodies do not do much into cancer. You really need to get into Th1 and cytotoxic T cells, and that's what they do. The cancer starts secreting chemicals that leads to polarization of the immune system away from cytotoxic T cell, which is into Treg and Th17 and Th2. And so knowing that the tricks of the cancer, knowing that the cancer, they end up shrinking into this fibrotic dense tissue of cancer stem cells. And once the chemotherapy and radiotherapy is over, then they go ahead and they flourish and they differentiate into aggressive cancer cell lines that is resistant to all the chemotherapy that has been given before. So they develop resistance there. And that's why they end up dying in the hospice. And if you they give them like 6 months and they may end up dying even before that, unless they go to the integrative doctors and they start giving them those treatments, which actually target the fibrosis and the cancer stem cells. And that's the reason why we as integrative doctors, we are finishing the job. Finishing the job of the oncologist, but does not mean that we discredit what we have. I mean, I will still continue doing chemotherapy and radiotherapy. What I will do it more smart. I will load those chemotherapy into platelet nanoparticle. I will use 10-20% of it because I'm concentrating those drugs into the cancer tissue more than giving it, better than giving it as a naked. Same thing for immunotherapy. You can load inside platelet nanoparticle as well, and I can teach the doctors how to load drugs inside platelet nanoparticle. I already taught 10 doctors to do that, but I need more of doctors. So if you're interested in loading drugs inside platelet nanoparticle, reach out to me at my website, cdpmcs.com, and I can help you to train. I'll go to your place and I will give you all the tools to learn how to load drugs inside platelet nanoparticle. That's very critical. In order for you to become CDPM, the first thing you need to know is how to load the drugs into platelet nanoparticle. Because it's not just for cancer, but also for regenerative therapies. Like if you want to inject into your joint, you can load thymosin beta and BBC 157, and even low dose cortisone if you want, or any injectable, anti-inflammatory injectable, ketorolac or anything, and then you can load inside platelet nanoparticles. You can get better results because they target the synovial membrane. We don't claim that we're targeting the cartilage cells because it's not that much effective in rebuilding cartilage, but we rejuvenate the synovial membrane. That's a message that I'm trying to give it to those people who are doing regenerative medicine and joints, that they are increasing the lubrication and the quality of lubricants versus rebuilding the cartilage. And it's very good. It's very effective. And that's the right claim that regenerative medicine is doing. So, but let's go back to the cancer side because, and cancer is actually abnormal regeneration. It's a regenerative disorder. That's the cancer, right? And that's the reason when we are presenting chronic disease prevention and management as a new field of medicine, because it has unique pillars that everybody needs to follow to manage any chronic disease across all medical specialties. It is restoring and modulating the redox, metabolic, immune, and regenerative. And if you follow those guidelines or those principles, you can apply it for any chronic disease out there, including cancer. And that is the field that I'm entertaining. And I think with the support of American Medical Association, because they're entertaining the same field, it's called CDPM, and they come up with redefining history and physical exam, which is called the 360 HP in their website. They have a group of CDPM. I went farther and I say we need to also redefine the way that we treat and manage and diagnose patients by looking at those 4 pillars, which are the redox, metabolic, immune, and regenerative. And so now we understood that, those integrative doctors, they are using all these therapies, which will definitely help to break down the fibrosis. And we are targeting certain metabolic pathway that's specific for cancer stem cells that we're going to see them in the coming slide. And, especially, there's something that's called WNT signaling. That's what we are targeting to eradicate cancer stem cells. And ivermectin does target that signaling. And mebendazole works on the microtubules of the mitosis, and they cause them to be halt. And I think that's how they help in managing cancer stem cells and also cancer in general, but cancer stem cells specific. in addition to Hodge-Hog pathway. It's being blocked as well by mebendazole. And ivermectin is very good also in blowing the mitochondria, because the mitochondria, it's like a ticking bomb. And what we need is first to activate them because they are sick due to chemotherapy and radiotherapy. So activate them and then blow them up. And we activate them with methylene blue and alpha lipoic acid and NAC and QQ10 and resveratrol and polyphenols. And then we can blow them up with ivermectin. Also, photodynamic therapy will help to blow them up. And once you blow them up, they release cytochrome oxidase, and that induces apoptosis for the cancer. And so you will see in the coming slides all the mechanism of how ivermectin and mebendazole is targeting those specific metabolic pathways for cancer stem cells, is also dissolving or targeting the fibrosis. Those are two problems that we have in cancer. And once you get rid from the cancer stem cells, and once you get rid from the fibrosis, and you open up those blood vessels, allowing the red blood cells to go in, carrying the oxygen in, which is very important because without oxygen, the chemotherapy and radiotherapy will not work. That's one way of how the cancer is protecting itself, is producing this fibrosis to squeeze the blood vessels to prevent infiltration of red blood cells, not just lymphocyte infiltration, but also red blood cells, and that will prevent oxygen from going in. And then you don't have enough oxygen to generate enough of free radical to induce apoptosis, because apoptosis is mediated by oxidative stress. Yes.
Dr. Halata, this is Dr. Patel. Can you go a little slowly? You're talking too fast.
Okay, I will go very slowly. Yes. So basically, the fibrosis itself that we have in those cancer, they are squeezing those blood vessels, preventing the infiltration of red blood cells and lymphocytes. So it's not just preventing lymphocyte infiltration with cytotoxic T cells to kill the cancer, but also the red blood cells. And the red blood cells carry the oxygen. And so that's why, although the cancer is hypervascular, yes, but they are being squeezed, they're being strangulated by the fibrosis. It's a smart way, so they have hypoxia. But those blood vessels are still delivering enough of sugar, right? Because they're hypervascular. And they think that small molecules, they can pass through. But bigger molecules, it can be, the fibrosis will squeeze them out and prevent them from going in. Especially at the size of the red blood cells and lymphocytes, and maybe even some I believe that maybe in the size of exosomes cannot pass, or big molecules like chemotherapy cannot pass, and they just allow the smaller molecules like glucose to pass. That's how much the cancer can squeeze those blood vessels to that point to protect them from chemotherapy and from lymphocyte infiltration, and also from red blood cells carrying the oxygen. And when they're being deprived by oxygen, what would happen to those cancer? They say, okay, well, that's better because I don't want mitochondria to work. Mitochondria is an enemy of the cancer because the mitochondria is a ticking bomb. And if it's active in the cancer, it will blow up and release cytochrome oxidase and induce apoptosis. So the cancer is actually inhibiting the mitochondria and it's relying on glycolysis. And when they do their glycolysis, that's mean they build up pyruvic acid, which leads to acidosis. Acidosis is a good thing because it leads to fibrosis and it leads to dedifferentiation of the cancer cells into cancer stem cells. Plus, it leads to shifting of the immune system into Treg. Everything in favor of the cancer. Now, that's how the cancer cells are very smart. Plus, they secrete all the chemicals, including the VGF, to help in polarizing the immune system into Treg. So all those interleukin-10 and transforming growth factor beta, all of this helps to polarize the immune system into Tregs and Th17, especially with interleukin-6. And this will compromise the killing of the cancer because it will compromise the polarization of the immune system to Th1 and cytotoxic T cells, because that's what we need to kill the cancer. So going back, that we know that the ivermectin and even mebendazole do help in breaking those fibroses, and we're going to see the old mechanism there. Especially ivermectin do have antifibrotic effect, same like losartan and same like other antifibrotic drugs that we're going to list them in the coming slides. So that's how and the reason, but we're going to go through those slides to come up with, to explain more detail about those mechanism of action. So now you have the explanation to those regulatories and to your neighbor oncologist of why you're using ivermectin, because you want to target the cancer stem cells, because ivermectin does target the cancer stem cells and the cancer fibrosis plus many more. It does also help in blowing up the mitochondria and induce apoptosis. So the chronic disease prevention management centers implement a uh, systemic biology and approach to cancer reversal, targeting the foundational disruption and redox status. Same like any other way we're managing any chronic disease, we look at those four pillars, which is the redox, metabolic, immune, and regenerative. And in cancer is kind of disorder and regenerative. It's this dysregulation and regenerative capacity where they are proliferating without any check. So the immune and regulation and also fibrosis. Yeah, fibrosis is the way that the cancer is protecting itself. It's like a shield, and it strangulate those blood vessels to prevent infiltration of red blood cells and the lymphocytes. Within this paradigm, two proposed repurposed antiparasitic drugs, which is ivermectin and mebendazole, have demonstrated significant anti-cancer properties, particularly in suppressing cancer stem cells and remodeling the tumor microenvironment. Tackling the fibrosis and blowing up the mitochondria. This article outlines the mechanistic rationale for incorporating ivermectin and mebendazole into integrative cancer protocol, supported by pharmacogenetics profiling, redox monitoring, and novel delivery platforms such as cyclodextrin and nanocarrier and platelet-targeted platelet nanoparticles that we are using to deliver those drugs into the pathology. So all the time, we recommend everybody to load those drugs in cyclodextrin or load them in platelet nanoparticles, or load them in both if you can. Compounding pharmacy can help you to load your injectable into cyclodextrin, and then you take those compound and you can load in platelet nanoparticle. But without even cyclodextrin, still you can load them in platelet nanoparticles and still get good results. And that's what we do. And I think all the CDPM affiliate doctors who are being trained to load drugs inside platelet nanoparticle, once they start doing it, they never go back, because that's the way to really target the drug into the pathology. So the CDPMCS cancer philosophy is reprogramming the cancer ecosystem. So it's not just killing the cancer. Most of the mainstream medicine and the big pharma is all figuring out what's metabolic pathway that the cancer we can target, what enzyme, what receptors. So it's all about they focus on killing the cancer, but we're focusing also not just killing the cancer, but also the changing the ecosystem, the tumor microenvironment, to become a hostile environment for the cancer. So cancer is no longer viewed solely as uncontrolled cell proliferation. CDPMCS define it as a multi-factorial system failure involving. So it's not just, cancer is not just because of they mutate and they start dividing uncontrollable, and that's it. I think it's more than that. It's also has to do with redox imbalance, oxidative stress, promote genomic instability and treatment resistance. So when you have oxidative stress, and cancer is living in oxidative stress that's higher than the normal tissue. And that oxidative stress we call the redox potential is a little bit higher than the normal tissue. And that drives the cell to divide and proliferate, not that high to induce apoptosis, but in between apoptosis and the normal healthy cells, the redox potential. So they are relatively positive. As a redox potential, the cancer tissue are positive redox potential relatively to the healthy tissue. And that's why when you give methylene blue, you will see the cancer tissue, they stain with blue because they get oxidized by the cancer tissue, because they have too much of free radicals than the normal healthy tissue. While the normal healthy tissue can reduce the methylene blue and they lose their color. When the methylene blue is methionine blue, when they get reduced, they lose their color. And that's why the healthy tissue, you see them that they don't get stained and the cancer gets stained because the methylene blue is oxidized in the cancer. Due to the cancer itself, it has a lot of oxidative stress and free radicals. And those oxidative stress, it drives the cancer proliferation and division uncontrollable, but also it causes the mutation. And the mutation is the problem because once those targeted enzyme by the chemotherapy is being mutated, then those chemotherapy will not work anymore. And that's how they are developing cell lines to lead to cancer resistance. And that's one of the problem where we're chasing the those flipping of those cancer and finding another drug that interfere with that metabolism or trying the way to override the resistance. Metabolic reprogramming tumor favor glycolysis even in oxygen-rich environment, which is called the Warburg effect, enabling survival and immune evasion, right? So basically the cancer, they favor they don't like the mitochondria to be active because the mitochondria is a ticking bomb for them. So they suppress it. So how they get energy, they get it from glycolysis. But then when you do glycolysis, you end up with acidosis, and that's fine. The acidosis will actually help the cancer because it will de-differentiate the cancer cells into cancer stem cells. It will shift the immune system into Treg, and it will enhance more of fibrosis. So everything it's in favor of the cancer. So that's what they do. We call it Warburg effect, and that's the reason. In order to kill the cancer, you need to activate the mitochondria using the polyphenols and curcumin and all that, and then blow them up, right, with photodynamic therapy or ivermectin. It does help to blow them up, release cytochrome oxidase, and get rid from it. So we need to shift the acidosis into alkalosis or alkaline. Because once you activate the mitochondria, you start burning those pyruvic acids, and that will lead to decreased acidosis, and that will help to decrease the fibrosis, and that would help to decrease the squeezing of the blood vessels and allowing the infiltration of farther more oxygen-tolerant red blood cells and infiltration of the lymphocytes. So we are reversing the whole thing that the cancer is doing just by activating the mitochondria and inhibiting the glycolysis. Immune suppression, tumor-induced regulatory cells and checkpoint molecules blocking the effective immune clearance. That's what they do. They increase expression of PD-1s, right, which will block those T cells and make them to differentiate into Tregs. So they are shifting the immune system by expressing those blockades, which is the PD-1s, and they make them to shift to the immune system to become Tregs in a state of cytotoxic T cells. So that's need to be blocked, and we use anti-PD-L1 and anti-CTLA-4. Again, it's better to be loaded inside the platelet nanoparticle to get them into the pathology versus going everywhere. And the acidosis itself, it helps also to shift the immune system into Tregs as well. But we have solution for that using anti-PD-L1, anti-CTLA-4, and all those immune modulators to polarize the immune system back into Th1 and cytotoxic T cells. So again, as I said, we're using all the 4 pillars of the chronic disease prevention management and managing anything, including cancer. So we consider cancer is regenerative dysregulation, and cancer stem cells drive recurrence, yes, because those cancer stem cells, as we know, they behave like normal cells. They have very strong antioxidant machineries to neutralize the free radicals, so they're very resistant to chemotherapy. And then they can emerge and differentiate in different lines that is completely resistant to the chemotherapy. Once the chemotherapy is over, the regimen of chemotherapy is over, or the radiotherapy regimen is over, then those cancer stem cells, they start differentiating and growing and start spreading all over and killing the host. And yes, so they're very resistant, and that's why we need to figure out how we can target those cancer stem cells. What there's is any metabolic pathway that's special for cancer stem cells that we can target and destroy it. How we can get rid from the cancer cells. So we need to get to learn all the tools that helps to get rid from those cancer stem cells and the cancer fibrosis. So this framework necessitates a multi-targeted therapeutic strategy as employed by CDP-MCS. And so, this is what we are going to do in the coming slides, is to figure out all the tricks of the cancer, and specifically the cancer-associated fibrosis and cancer stem cells, and then also see how repurposing drugs like ivermectin and mebendazole, how they are working in targeting those two issues that we have, which is cancer-associated fibrosis and cancer stem cells. That's what we're going to focus in this lecture. I think the previous lecture that we have last week is talking about all the tricks and all the treatment in general, but I want to focus this time on validating the treatments of using or the use of ivermectin and mebendazole in managing cancer, especially in getting rid from the cancer stem cells and the fibrosis. So ivermectin do inhibit the Wnt and B catenin signaling. They block those B catenin accumulation into the nucleus, and that itself will lead to decrease or the cancer stem cells that inhibit the cancer stem cells by suppressing the Wnt and B catenin signaling as central driver of cancer stem cells and self-renewal, and also the chemo-resistant. It reduced the nuclear accumulation of B catenin, thereby decreasing the cancer stem cells markers like CD44 and ALDH1. So basically, this will inhibit the pathway that's very critical for cancer stem cells. This will lead them to die and induce apoptosis, right, and stop them from dividing. And how you can monitor the efficacy of ivermectin? Well, those cancer stem cells, they express the CD44 and ALDH1. So when I'm using ivermectin, I'm expecting the cancer stem cell load of those cancer will decrease. But how I can know that? By assessing the CD44 and ALDH1 expression. And you can do that with using RGC lab or other labs that's there, so you can monetize the efficacy of your cancer stem cell therapy using ivermectin. And so they inhibit the nuclear accumulation of beta catenin, and this will lead to inhibition or prevention, or it will stop the renewal and proliferation of the cancer stem cells and induce apoptosis and kill those cancer stem cells. And this will lead to decrease their markers, right? When you are killing those cancer stem cells with ivermectin. And that's how you know whether your ivermectin is working or not. So after maybe 6 months of treatment, you first of all you measure the expression of CD444 and ALDH1 with the lab, and then after your course of treatment, you go say, okay, let's see if the ivermectin did work or not, and decreasing the load of cancer stem cells. Let's see if the expression of those receptors being decreased, and you can get that from those labs. And then you can report it to your patient, say, hey, this is what we did. So we are tackling your cancer cells. That's a success. In addition to that, when you're monitoring the efficacy of your treatment and shrinking the cancer, it's not just enough to check the size of the cancer from the starting of treatment to the end. Cancer shrinking and measuring the size, it's good to know, and that's very important, but also the consistency of the cancer tissue. Is it hyperechoic? Hyperechoic means a lot of fibrosis. That's not good. So you need to come up with a treatment that breaks down the fibrosis. And then when you're doing your ultrasound, you're going to see the change in the consistency of the cancer from hyperechoic into echoic, or something that's near to the parenchyma or the surrounding healthy tissue. That's a progress. So it's not just shrinking the size of the cancer, but also trying to reduce the echosity or the density of the cancer, and you can see that through reducing the hyperechoic into become echoic as much as you can, near to the normal surrounding tissue consistency under the ultrasound. That's mean you are breaking the fibrosis, and that's very, very important sign of the progression of your treatment. It's working. The other thing that ivermectin does, it does inhibit the mTOR. So by inhibiting the P21 activated kinase, that's what the mTOR, the ivermectin does. It suppresses the mTOR pathway, which is essential for cancer metabolism and cell survival. So now the other target is that ivermectin does inhibit the mTOR, right? An equivalent of that inhibit the mTOR, which is the adjuncts, is metformin, berberine, all of those activate the AMPK, which will enhancing the mTOR inhibition and metabolic disruption. So that's one way of the mechanism. So when you have the mTOR, you have the drive of the proliferation of the cancer, and you stop the cancer from dividing, and this will help to get rid from the cancer stem cells as well. So you give ivermectin, and you can give them metformin or berberine or any of those inhibitors of mTOR like rapamycin. Um, so ivermectin does work like like rapamycin in terms of blocking the mTOR. As we know, the mTOR is the drive of the cancer cell proliferation in general, but specifically for those cancer stem cells. So that's one way, or one of the second mechanism of how the ivermectin is helping in killing those cancer. Okay, so we talked about that we need to those chemotherapy, radiotherapy makes the mitochondria sick, right? And the cancer stem cell, cancer cells also, they secrete chemicals to make the mitochondria sick and block them. So we need to make those mitochondria to be active. We are not activating it so they can operate in the cancer and generate energy for the cancer. No, we're activating it to blow them up and shifting the acidosis into alkaline. Once that's been active, then you are shifting from glycolysis to oxidation phosphorylation, and you are burning those pyruvic acids. So you're decreasing acidosis, and that's very important. But also you're generating enough of free radicals inside the mitochondria, right? And then what will happen? You have enough of mitochondria ready and then you give them some methylene blue with photodynamic therapy, or you give them ivermectin, and it will help to disrupt the membrane and blow them up, release cytochrome oxidase, and induce apoptosis. So ivermectin increases intracellular ROS level, leading to mitochondrial membrane depolarization and cancer cell apoptosis, particularly in glycolytic tumors, right? Yeah. So basically, it will first activate the mitochondria and then activate it will cause the membrane depolarization and release of those free radicals, and enough to kill the cancer. As we know, the cancer, yeah, they live in an oxidative stress redox potential that's higher than the healthy tissue, but still lower than the level that needs to be, that will lead to kill them, which is apoptosis. So what we're going to do, we're going to push them to the level of apoptosis by activating the mitochondria, which will help to accumulate those free radicals inside them, because when it's being active, you start consuming the oxygen and generating free radicals, and then you blow them up, you release all those free radicals enough to cause a burst. That burst will lead, along with cytochrome oxidase, will lead to induction of apoptosis and kill them. And synergistically, you can use vitamin C high dose, which generate enough of free radicals. Ozone, which provide the available oxygen that you need. Especially when all those cancer cells, they have fibrosis and they're squeezing the blood vessels, preventing red blood cells from infiltrating. So now you need to consider how you can get the oxygen inside the cancer cells into the core, right? And red blood cells not getting in, so the oxygen is not getting in. So you need to dissolve those plasma of the patient with oxygen, whether using oxygen chamber or ozones, to help to bypass that. Because now you're not relying on the red blood cells to carry the oxygen. You are increasing the plasma oxygen level, and you're getting it into the cancer, bypassing the fibrotic squeezing of the cancer and excluding the red blood cells carrying the oxygen. Yeah, and giving methylene blue, alpha lipoic acid, all this, and CoQ10 and resveratrol, and activating those mitochondria, that's a good thing, because they've been hammered already by the radiotherapy and chemotherapy, those mitochondria. So we need to get them back alive and then blow them up to induce apoptosis. So induction of mitochondrial apoptosis via ROS by ivermectin. Ivermectin induced mitochondrial dependent apoptosis in cancer cells by increasing intracellular reactive oxygen species. This mechanism is especially potent in glycolysis dependent tumor, such as many aggressive cancers, which have lower capacity to buffer oxidative stress, right? So that's what we need to do. We need to activate them first, get those mitochondria to be active, accumulating the lot of free radicals inside them, because now they're using the oxygen, right? Burning those lactic acids, and shifting the whole cancer environment from acidosis to alkalosis, which is very important because this will lead to breaking down decrease the fibrosis and helps to polarize the immune system back to Th1 and cytotoxic T cells. And so we are using ivermectin plus methylene blue plus all those polyphenols. I am and this all help eventually into blowing up those mitochondria and induction of apoptosis. So ROS generating ivermectin stimulate the production of ROS inside the cells. Excessive ROS overwhelm antioxidant defense like glutathione, and the mitochondrial membrane depolarize. ROS damage disrupt the mitochondrial membrane potential, right? It's too much of those reactive oxidation, leading to opening of mitochondria permeability and lead to transitional pores, which leads to cytochrome C release. Cytochrome oxidase C release, and once the mitochondria are compromised, cytochrome C leaks into the cytoplasm, and the cytochrome C activates the capsase 9 or capsase 3, leading to intrinsic apoptosis. So that's the detailed mechanism of how we are doing it. And adding vitamin C IV will do the same thing. It will increase their pro-oxidant, increase reactive oxygen species by the Fintone reaction. Ozone therapy will provide us the oxygen that we need for the mitochondria to be active, right? And they generate enough of free radicals as well. And alpha lipoic acid and all those polyphenols may help to facilitate the mitochondrial redox cycling, enhancing the ROS selectivity toward the cancer cells. So all of this would help in activating and blowing up the mitochondria and activating the bombs. Well, those mitochondria are bombs inside the cancer cells. And chemotherapy, radiotherapy, what they did, they inhibit those bombs. Plus, the cancer itself, they secrete chemicals to inhibit those bombs. And so now we know that we're going to need to activate them and then blow them up. Clinical significant selective to glycolytic tumor, especially a glycolytic tumor that relies on glycolysis. They are the one that are very sensitive. Triple negative breast cancer, for example, pancreatic cancer, glioblastoma, all those are glycolytic tumors, and definitely this strategy that we're doing of activating the bombs, which is the mitochondria, and blow them up. It's the best way to get rid from those cancer, and this will bypass the p53 resistance since apoptosis is mitochondria driven, right? So now we are not relying on p53. If you have mutated p53, that's fine, because we are not relying on that. We are relying on mitochondria inducing the apoptosis. So bypassing the p53 resistance. So if there's mutation p53, we can bypass that. Why? Because this is apoptosis is mitochondria driven, not reliance on nuclear signaling. Improving response when you use it with IV, vitamin C, ozone, and redox balancing protocols that we are doing, methylene blue, all those polyphenols that we're using. So now we have explanation to the mainstream medicine, to the regulatories, why we are doing it, why we're successful, why we're finishing the job of the mainstream medicine, why the mainstream medicine failed. We know now why, and now we are finishing their job. They're failing in eradication of the cancer, but they did very good at shrinking the cancer. So take advantage of that and start working on getting rid from the fibrosis and the cancer stem cells using your integrative cancer approach. Inhibition of importin alpha and beta mediated nuclear transport. The ivermectin blocks the importin alpha and beta. And so this is this is another mechanism of how ivermectin exerts one of its powerful anti-cancer effect by disrupting the nuclear transport of transcription factors, especially the STAT3 signaling and transducer and activation of transcription 3 and NFK beta nuclear factor, kappa chain, and activated B cell. These two proteins are master regulator of inflammation, immune suppression, and tumor progression. So I'm blocking those NFK beta by blocking the importin alpha and importin beta. And this will inactivate the NFK beta. We know those. We said that the cancer is a little bit redox potential is higher than the normal tissue because they have an active NFK beta. They're very active. And now we know the NFK beta, when it's very active, it may lead to interleukin 6. Interleukin 6 leads to polarization of the immune system to Th17. and that leads to neutrophils in the state of cytotoxic T cells. So it's not good to have overactive NFK beta, because that may lead to polarization into Th17, which is something that we don't want. And plus, the cancers all the time is more, the oxidative stress is higher than normal tissue, because that's the drive of the cancer cells to proliferate. They don't proliferate in a normal redox potential of the healthy tissue. They're a little bit higher, but below the apoptosis. So that at that level, and then they need to be maintained at that level. So if ivermectin inhibits that, then it will stop those cancers from dividing, and also it helps to prevent the interleukin 6 from production of excessive interleukin 6, which is help to change the tumor microenvironment in favor of the tumor growth. So block interleukin 6, or anything that helps to generating excessive interleukin 6 or interleukin 8, it's good for treatment of cancer. So that's what ivermectin does here. So in proteins, alpha and beta are nuclear transporter protein that acts like a shuttles. When protein like SAT3 or NFK beta are activated in cytoplasm, they bind to protein alpha, which forms a complex with protein B or beta, and this complex escort the protein into nuclear through the nuclear pore complex. Once inside, this factor activate the genes and promote inflammation, survival, and secrete all those cytokines like interleukin 6, and that leads to angiogenesis. That's mean they may end up secreting VGF, endothelial growth factor, and it leads to production of interleukin 6, which will lead to polarization of immune system to Th17 and neutrophils, and that's not good, right? That's change the tumor microenvironment in favor of the cancer, and we need to stop that by using the ivermectin. So the ivermectin now is changing the tumor environment to become hostile. It's counteracting the effect of the cancer in surviving by counteracting all those factors that leads to enhance the tumor growth, that makes the environment favor the cancer. So we need to counteract all of that. Ivermectin blocks the interaction between those cargo protein, STAT and NFK beta, and protein alpha and beta. As a result, this survival promoting factors are trapped in the cytoplasm, cannot activate the gene, cannot go inside the nucleus, and cannot activate the gene transcription in the nucleus. This inhibits the cancer cell proliferation, dampness the inflammation, it inhibits the Th17 specifically. And we know that the ivermectin does inhibit Th17, not just for cancer, but also for inflammation, especially for COVID, and enhance the immune detection of the tumor, because once you have the Th17, then the immune system will start polarizing into more into Th1. VGF, which is vascular endothelial growth factor, or they actually polarize the immune system to Tregs. And so inhibiting interleukin 6, which will inhibit the production of excessive VGF, it's all help, because this will inhibit the polarization immune system to Th17 by inhibiting the interleukin 6, by inhibiting the NFK beta and STAT3. And so, as I said, those transcription factors, effect of ivermectin, inhibition of translocation, reduce the tumor growth and immune suppression, right? Because, as I said, those chemicals or those NFK beta and STAT3, they express and secrete interleukin 6, which leads to polarization of the immune system into Th17, and that's not good. And also it drives the polarization to Th2 and Th17, right? And they start secreting those STAT3, FPC, they start secreting VGF and interleukin 10, and we know that the VGF and interleukin 10 do polarize the immune system into Tregs and Th2, and we need to stop that, right? So ivermectin does to stop that. So this will help to decrease the Tregs, the shield that protects the cancer, that leads to immune tolerance to the cancer. And as I said, the NFK beta, they also lead to interleukin 6. Interleukin 6 with transforming growth factor beta causes fibrosis, and it leads to all this inflammation, unnecessary inflammation, and the inflammation that does not kill the cancer, inflammation that causes the cancer to grow. Because because the Th17 mediated inflammation, Th2 mediated inflammation, which is mast cells activation or neutrophils, they will not help to kill cancer. In fact, it will help to drain the immune system away from what we need, which is the Th1 and cytotoxic T cells. And so inhibiting the STAT3 and NFK beta is very important. Plus, activating NFK beta is the reason why the redox potential of the cancer is higher than the normal tissue and that drives the cancer to proliferate and divide. So again, this blocking this reduces cytokines, especially interleukin 6, transforming factor alpha, and this will lead to change the microenvironment, of course, decreasing the fibrosis and make the environment more hostile for the cancer, right? So decrease the fibrosis, decrease the squeezing of the blood vessels, allowing the infiltration of lymphocyte infiltration of blood cells. So the key benefits of this mechanism convert the immune cold tumor to hot, right? So once we polarize the immune system into Th1 and cytotoxic T cells, that's a good thing. That's turning it from cold, from immune tolerance into immune activation against the cancer, immune intolerance, right? And then the fibrosis will be broken down. This leads to infiltration of the lymphocytes again. The cytotoxic T cells, natural killer cells will go in. So converting the immune cold tumors into hot by reducing the immune suppressive cytokines, which are the interleukin 6, interleukin 10, transformer growth factor beta. All of this will favor the shifting of the immune system into Th2, Th17, and Treg. We don't want that. We want the immune system to go to Th1. Synergize with Th1 stimulation agents like, and that you can add, again, thymosin alpha. I like thymosin alpha because it helps to increase the immune system, the Th proliferation in general, but shifting it more into Th1. So add thymosin alpha. It helps us definitely help and synergize with this. Limits the spread and invasiveness of the tumor by preventing the EMT gene expression and supporting, and also the supporting reference. Okay. So again, we are working on changing the tumor microenvironment in a way that it will be a hostile environment of the cancer by shifting the immune system into Th1 and breaking down the fibrosis, allowing the infiltration of lymphocytes, which is cytotoxic T cells, and Th1 into the cancer, allowing the infiltration of red blood cells carrying the oxygen again. All of this would help to turn that tumor from cold to hot, reactive environment. So let's go to antifibrotic effect of the anti-cancer drugs. One of the most critical challenges in treating solid tumor is the presence of fibrotic tumor microenvironment. And those fibrosis squeeze the blood vessels, preventing the infiltration of lymphocytes, especially cytotoxic T cells, and Th1 from getting into the core of the cancer, and also infiltration of the red blood cells. You need that red blood cells carrying the oxygen. So tumor microenvironment is dense, collagen-rich barrier that prevent immune cells and therapeutic agents. It can squeeze even big molecules and chemotherapy from going in as well. So that we need to break them, right? So that's the reason, you're giving all those chemotherapy, but they're not getting into the core of the cancer. You're giving them all that because of this too much of fibrosis. So we need to break them. And how we break them? We break them chemically using ivermectin, using losartan. You can use it mechanically using shock waves. So I'm designing, by the way, I'm working with manufacturers to design shock wave to break the fibrosis. And that's one thing that I'm doing currently. And that's what we need. Those are unmet medical need. And those shock waves has to have specific, not the shock wave for regenerative medicine. Those sound therapies, their frequency and the watt, it needs to be specific for the application. So maybe the specification for breaking down the fibrosis is a little bit different from the specification for regenerative therapies. And that's what I'm doing. I'm creating a shockwave specifically to break down the collagens or the cancer-associated fibrosis. So this collagen-rich barrier that prevent immune cells and therapeutic agents from effectively reaching the tumor core, this fibrotic shield is largely formed and maintained by the myofibroblasts, which are activated fibroblasts driven by transforming growth factor beta. So basically, the cancer itself, they secrete transforming growth factor beta. And that leads to differentiation of fibroblasts into myofibroblasts. And the myofibroblasts will lead to secretion of all those collagens. And that leads to the shielding of the cancer and squeezing the blood vessels and everything that helps the cancer to grow and proliferate. So what does and how it works, ivermectin? It does inhibit the effect of transforming growth factor beta signaling. So ivermectin inhibits transforming growth factor beta signaling. It inhibits the conversion of the fibroblasts into myofibroblasts, thereby degrading the fibrotic matrix and protects the tumor from the immune attack and the drug penetration. So we need to break those fibrosis to allow those drugs to go in and allow the infiltration of the lymphocytes and allow the infiltration of the red blood cells carrying the oxygen and turning those cancer from cold cancer into hot cancer, right? And so when we do the CT scan, PET scan, and we see those dense cancer tissue are shining because of the glucose is accumulating those cancer, that actually means that you have too much of fibrosis there, which squeezes the red blood cells, preventing oxygen from going in, and then the cancer stem cells will start working on generating energy by glycolysis and blocking the mitochondria. All this needs to be reversed, and we need to work on breaking those fibrosis. So antifibrotic drugs are very important in managing cancer. I don't think the oncologists have a clue about this thing. The current mainstream medicine, oncology, they don't care about tumor micro. They don't even see it. It's not in the curriculum. It's not in the pages of the protocols of the big pharma that has been sent to them. And now the integrative doctors, they finding why. What's the reason? Why those oncologists fail? Why the cancer is still there? Yeah, it shrinked, but beyond that shrinking, beyond the 10%, we cannot do anything. All those chemotherapy is not working, radiotherapy is not working, immunotherapy is not there, and still that cancer is still there in a very dense fibrotic tissue there. We see it on the ultrasound, and we cannot go beyond the 10%. That's, of the original size. Now we know how, right? Now we have the tools. Now you have the education. Now you have the protocols. And we can do more. It's not just relying on those drugs. We can go ahead and put a cocktail of drugs that's antifibrotic, peptide supplement and drugs, and we can reach out to the compounding pharmacy and say, I need this cocktail to be produced. It's antifibrotic. And that's what I'm doing. I can help you to get there. And I help you with all the dosages. I can help you to create those 500 milligram supplements, or in other words, drugs that's made from supplements, peptide, and drugs that's breaking down the fibrosis or breaking down the cancer stem cells. And it's better to be multi-therapy than one therapy. So if you have all these antifibrotic drugs, many of them put together in one capsule or injectable, same thing we can do for cancer stem cells, whether injectable or oral. And I can help you to do that. You just reach out to me and I can help you to develop those protocols and develop those treatments. Okay. So the mechanism of ivermectin is inhibition of transforming growth factor beta signaling, which is a key cytokine that promotes fibroblast activation, epithelial to mesenchymal transition, and collagen deposition, right? Which is the AMT. And ivermectin interferes with transforming growth factor beta's SMAD pathway, reducing the transcription of fibrosis-associated genes. So eventually, I'm getting rid from the fibrosis of the cancer, which is called cancer-associated fibrosis. And I'm allowing the infiltration of the lymphocytes and red blood cells and drugs back to the inside the cancer. To enhance this anti-fibrotic effect of ivermectin can be combined with, you can add nattokinase, streptokinase orally, fibrinolytics that dissolve extracellular mesenchymal tissue or those fibrosis. Shockwave therapy, mechanically disrupt the fibrotic stroma, and that's what I'm developing. Photodynamic and photodynamic therapy, which will oxidize the fibrotic tissue with ROS. And I can help you. This photodynamic therapy, there's focusing ultrasound, which has its own specification that helps to oxidize or breaking down those fibrosis as well. If you do photodynamic therapy, that's mean you have to have sonosensitive drug that will absorb those ultrasound energy, generate free radicals that leads to damaging those fibrosis by oxidizing them. And then you add AMPK activators like metformin, which will help to suppress the fibrogenic pathway as well, right? And the proliferation of the fibroblast to myofibroblast. Doing that, you can help in changing the tumor microenvironment to become a hostile environment for the cancer. So ivermectin's antifibrotic effect is not just supportive, but central to its role in cancer reversal. By dismantling the tumor physical defense system, ivermectin opens the gates for immune reactivation, as we said, infiltration of lymphocytes. Therapeutic axis, right? Because they can squeeze those blood vessels to the point they can, even the big molecules cannot pass. And they just allow the smaller molecules like glucose and whatever essential nutrition for the cancer. This is how much the fibrosis. Plus the fibrosis itself, you know, when you do radiotherapy, they can shield and absorb the radiotherapy effect and absorb it, where those radiation, they don't generate the free radicals because it's hitting the fibrosis itself. So the fibrosis protects the cancer from radiotherapy, from chemotherapy, squeeze the blood vessels, preventing the blood cells from going in, preventing oxygen from going in. You don't have enough oxygen for the chemotherapy to work. Even radiotherapy, you need to have oxygen because radiotherapy works by increasing the free radicals. Photodynamic therapy will not work without breaking those fibroses. You know, that's the reason I failed to manage my dad when he has cancer. We did all the thing like photodynamic therapy, low dose chemotherapy activated with light, but I don't see the cancers being stained by the methylene blue. I don't see that the drugs is getting into the cancer. And the reason, because at that time I was unaware about fibrosis. That is a challenge of eradicating the cancer. Now I know. And I know the reason why when I try the first time when you did methylene blue, it's staining the cancer, then it's not anymore. Seems like the fibrosis squeezed the blood vessels to a point even methylene blue cannot pass. And then the other thing is that the cancer stem cells itself, it behave like a normal cells where they have enough of antioxidant machineries that will neutralize those methylene blue and they become transparent. I mean, another word, they lose their color. So that's why the cancer is not being stained. So there are many reasons. Some good fibrosis, some the cancer stem cell itself is behaving like a normal cells. So now we need to figure out how to get rid from the cancer stem cells by breaking the fibrosis and also looking at the pathways that's specific for cancer stem cells like the WNT. Those are pathway for cancer stem cells, and we can targeting using mebendazole and ivermectin, as you see it here. So here just shows you the ivermectin inhibits the transforming growth factor signaling, inhibit the myofibroblast activation, therapy degrading the fibrotic matrix that protects the tumors from immune attack and drug penetration. Again, you need to add all others antifibrotic drugs, chemicals, supplements, peptides, which I have the list of them. And we can create a cocktail of cancer fibrolytic drugs, cancer stem cell cidal cocktail. We can create that together. Now let's move to mebendazole. Mebendazole, a disruptor of proliferation, angiogenesis, and cancer stem cell signaling. And how they work through attacking the microtubules of the mitosis and preventing that process of cell division and leading to mitotic arrest, and that leads to apoptosis. So the mebendazole binds to beta tubulin, arrests the cells in mitosis, and leading to apoptosis. When you stop it, then they will end up dying. This is effective in high proliferation tumor with elevated KIS7 expression. So when the cancer stem cells start dividing, and especially when the end of chemotherapy and radiotherapy, and cancer stem cells now it's ready because there's no hostile environment for them anymore, so they stop proliferation. It's good to give them mebendazole to prevent that from happening. So that's part of your strategy here. Plus, it does help to kill the cancer stem cells as well by doing that. The cancer stem cells will not proliferate as well. But also, when the cancer stem cells wants to proliferate and differentiate, this is a good time when you put the mebendazole. So after the mainstream medicine finish from their work, and they send you a patient with fibrotic cancer stem cells, right, metastasis, stage 4, stage 3, then that's where you start working as integrative doctors to work on the rest, or the things that they're missing, which is the cancer-shaped fibrosis and the cancer stem cells, using the tools that we are talking about. So also, you can also blow up the mitochondria using mebendazole. Same thing like ivermectin. Mebendazole induce intrinsic apoptosis, a form of reprogramming cell death originating within the cell by disrupting the mitochondrial integrity. This particular important in p53 deficient tumors, which are often resistant to conventional apoptosis triggers, right? So basically, if you have a cancer that has already mutated p53, you want to bypass that, you can go ahead and activate the mitochondria first using all these polyphenols and thiols, and then use photodynamic therapy, or use mebendazole to disrupt that mitochondrial membrane, release the cytochrome oxidase C, and induce apoptosis. So that's what we can do, whether through ivermectin or through mebendazole or through photodynamic therapy. And the cytochrome oxidase will lead to activation of capsase 9, capsase 3, and then lead to apoptosis. And that's what we can do, is first to activate the mitochondria and then to blow them up with mebendazole and photodynamic therapy. So the mechanism explained mitochondrial dysfunction. Mebendazole causes loss of mitochondrial membrane potential, damaging the mitochondria outer membrane. This leads to release of cytochrome C from the mitochondria into the cytoplasm. And this led to apoptosome activation, with cytochrome C binds to APA F1 and procapsase 9 in the cytoplasm to form apoptosome. This complex activates the capsase 9, which turn activates the capsase 3 and execute apoptosis. So this is p53 independent. So if you have mutation p53, don't worry. We can bypass that using this method. Most chemotherapy relies on p53 tumor suppressor genes to induce apoptosis. They activate the p53. Or you're using, for example, exosome from umbilical, and you say I'm introducing the p53 into the cancer cells, and it helps to kill them, because we know that umbilical exosomes, it's a sword with two edges. It does have growth factors, but also it does have some anti-cancer effect. Anti-cancer effect is the p53 that the cancer stem cells will be introducing to, or the cancer exosome will introduce into the cancer stem cells of the cancers. But we can bypass, if the p53 is mutated in that cancer, we can bypass it using by blowing up those mitochondria using mebendazole or photodynamic therapy. So this is very good for p53 mutated or deleted tumors. To amplify the mebendazole-induced apoptosis, this adjunct removes survival of checkpoints, making it easier to cytochrome C release to trigger cell death. Other things we can add is BH3 mimetics, which blocks the anti-apoptotic drug is called the venetoclax. The venetoclax is a drug that we can help the mebendazole in blowing up the tumor or destroying the tumor. So we can block the BH3 mimetics and BCL2 inhibitors. All of this will help in blowing up the mitochondria and induce apoptosis. And so we can add another drug to it. It's called the venetoclax. So tumor type, p53 mutant tumors resistant to apoptosis. We can bypass that using apoptosis via mitochondrial pathway, using mebendazole, ivermectin, and many others. Photodynamic therapy with methylene blue, for example. Glioblastoma, melanoma often is BCL1 overexpressing and potentiated by BH3 mimics. We can use that as well, the BH3 mimetics. And the chemo-resistance cancer adapted to avoid extraction death, intrinsic trigger circumvent resistance. All of this, this will help to bypass p53 mutation or chemo resistance by using those anti-parasitic drugs, repurposing it. Therapeutic advantages works even in tumor resistance to external apoptotic signals, right? When you have p53 mutated, it's not working, then all those drugs that relies on it, they will not work, so we can bypass that. Synergize with modern apoptosis targeted therapies like photodynamic therapy, preserve healthy tissue due to its tumor selective mitochondrial stress. The good thing about those drugs that they are more selective to tumor mitochondria versus the normal mitochondria or mitochondria in the normal healthy tissue. So that's the beauty of giving those drugs. Mebendazole, they work on the mitochondria of the cancer cells and they don't work on the healthy tissue. So that's a very big plus. Otherwise, if it's going to be toxic to all the mitochondria, it's going to be a disaster. So there's some selectivity there. So the other pathway that we need to target the cancer stem cells, they use what we call the Hodge-Hogg and Wnt pathway, and we can target them with ivermectin and mebendazole. So cancer stem cells are smaller subpopulation of tumor cells responsible for recurrency and metastasis and resistance to therapy, because as we know, all the differentiated cancer cells can be eradicated or got rid from by chemotherapy, radiotherapy, and the immunotherapy. And what's left is the cancer stem cells with fibrosis. That's where they are resistant to all those traditional mainstream medicine therapies. And now we need to figure out how to kill those cancer stem cells and how to break down the fibrosis to allow the infiltration of the drugs inside them. So targeting the Hodge-Hogg and Wnt pathway is one way to get rid of those cancer stem cells. They maintain their self-renewal and pluripotency through the development signaling pathways, particularly the Hodge-Hogg and Wnt pathway. Mebendazole inhibit both of these key signaling systems, thereby suppressing the cancer stem cells maintenance, proliferation, and resistance mechanism. So that's what we are going to do, is to inhibit those signaling pathway. And then how you know it's working or not? Well, let's say the cancer stem cells, they express the CD44 and CD4H, and we can monetize the efficacy by using some genetic testing for those receptors. And if it's low before and after, then we know that our treatment is working in tackling so the cancer stem cells. So Hodge-Hogg pathway inhibition, key protein involved in smoothing SMO, a G protein coupled receptor that activates downstream signaling, the GLI1, a transcription factor that enters the nucleus to activate the stimulus and the survival genes. So that's what we're doing. We're inhibiting the Hodge-Hogg, and we are inhibiting the GLI, and then we are inhibiting the whole survival signaling of the cancer stem cells. Mebendazole action blocks the SMO activation and GLI1 nuclear translocation, as you see it here in the illustration, and it downregulates transcription of the the cancer stem cells markers like NANOG and SOX2 and OCT4. And all of those markers, we can use them to monitor the efficacy of the treatment. So by blocking the Hodge-Hogg and Wnt signaling pathway, which is specific for cancer stem cells, then we can decrease the load of those cancer stem cells, and we can end up into eradicating the cancer, right? especially after the chemotherapy and immunotherapy regimen and all that. They fail to eradicate. They may shrink the cancer, but they fail to eradicate because they don't touch the cancer stem cells and they don't do much into fibrosis. Now we know where's the problem and how to solve it by repurposing those drugs. And again, there's other drugs that works the same thing that we can use, and we can form a cocktail of those anti-cancer stem cells. Cocktail of peptide drugs and supplements, including mebendazole and ivermectin, that will target the cancer fibrosis and the cancer stem cells. So the Wnt beta-catenin pathway inhibition, the key point involved Wnt ligands, which is frisled receptors, B-catenin stabilization. B-catenin translocates to the nuclear, which that's going to be blocked by the mebendazole and promote gene linked to cancer stem cell survival, which is CD44. And we see that once we get rid of the cancer stem cells using these drugs, you see the expression of CD44 and ALDH1 is decreased. And so mebendazole action inhibit the Wnt signaling and prevent the B-catenin stabilization, leads to cancer cell differentiation or apoptosis. So it either leads to differentiation or apoptosis, and both is good for us because once you differentiate it, it's easy to get rid from them, right? They're more sensitive to chemotherapy and immunotherapy when they are differentiated. So pushing it into differentiation or killing them is the way to go. And we can use that using mebendazole and other mimicking drugs. So cancer stem cell function is disrupted by mebendazole. And how we can do that by inhibiting the self renewal, the Hodge-Hog and GLI1 downregulation. That's what we do. And we can the cancer stem cells, chemoreceptors, definitely the resistance to chemotherapy can be we can overcome that by blocking the Wnt and B-catenin signaling blockade and blocking those cancer stem cells because they are the one who are resistant to chemotherapy, right? Because they behave like normal cells. They have enough antioxidant machineries to neutralize those free radicals. And so the reason why, we have tumor relapse and metastasis is because of those cancer stem cells. They're resistant to chemotherapy, immunotherapy, radiotherapy. And once the regimen of those therapies is over, then they start flourishing, dividing into a cancer line that's very difficult to get rid from, and they destroy the host. Now we know how to get rid from them, right? And reduce them and force them into differentiation. So once you infiltrate the red blood cells and oxygen, once you activate the mitochondria, and once you shift the acidosis to alkalosis, those cancer stem cells, they start differentiating into cancer cells. And that's where we can get rid from them easily by low-dose chemotherapy, photodynamic therapy, or all other therapies, that immunotherapy and all that stuff. So all of this are working together synergistically with whatever we have. We don't throw what we are using. We just make them more effective. All those chemotherapy, immunotherapy, and radiotherapy, we're still going to use them, but we're going to be more effective. So radiotherapy, you can use radiosensitive drugs like methylene blue and cyanine green, and that helps to increase sensitivity, or use chemotherapy like cisplatin. They are radiosensitive. Chemotherapy, you can activate them with light, so it's called low-dose photoactivated chemotherapy. Immunotherapy, you load them inside place nanoparticles, but all of them you can load inside place nanoparticles like this. So you're making what's the tools that the mainstream medicine have, you make them more smarter, like smarter bombs instead of blind bombs. And then also you work on the fibrosis and the cancer stem cells and the angiogenesis. And all of this it's part of your treatments. And then very important, those markers that you can learn it from RZC Lab. It's a good one, and others. You can monitor all those markers and knowing the effect of your drugs. All those drugs has effect of certain markers, right? We saw those cancer stem cells. Okay, we're getting around cancer stem cells. Let's decrease the expression of cancer stem cells. How we can see that? By monitoring those genetic testing that we do. Mebendazole, while powerful on its own, its targeting cancer stem cells becomes significantly more effective when combined with therapies that complement its mechanism. These synergistic agents either enhance the immune targeting, break through the fibrotic barrier, or push the cancer stem cells toward terminal differentiation, making them more susceptible to differentiation. So adding thymosin alpha is a good thing to do. Adding photodynamic therapy, adding retinoic acid, vitamin A, it's very important because it helps to differentiate and adding those HDAC inhibitors as well, which will promote cancer stem cell differentiation and make them more sensitive, right? Mebendazole is targeting those residual cancer stem cells in those fibrotic zones, and destroy them as you see it here. And then thymosin alpha, which help to polarize the immune system into Th1 and enhance the immune recognition of the cancer stem cells. So thymosin alpha enhances the immune recognition of the cancer stem cells. As we know, the thymosin alpha is a thymic peptide that stimulates dendritic cells. It stimulates the CD8, the cytotoxic T cells, the natural killer cells. It shifts the immune response from Th1 into Th2 to Th1. That's what we need. And it's a critical switch for tumor clearance. So cancer stem cells typically evade the immune detection due to low antigen expression and major histocompatibility and down regulation. So this thymosin alpha helps to turn those cancer stem cells and activate the immune system and make those cancer stem cells more visible. Mebendazole reduce the cancer stem cell signaling and stimulus, and this will definitely help because once they get differentiated, then they have this major histocompatibility complex, then they can be easily recognized by cytotoxic T cells to destroy them. So adding mebendazole with thymosin alpha is very critical. Adding ozone therapy is very critical because you can bypass the fibrosis that's preventing infiltration of red blood cells carrying the oxygen. So when the oncologist calls you and say, hey, don't add ozone to my therapy, don't thymosin alpha, don't do anything, tell them, hey, we are helping to enhance the efficacy of your chemotherapy. Your chemotherapy needs oxygen. And the cancer is squeezing those blood vessels, preventing your chemotherapy from going in, preventing from oxygen from going in. So I'm helping you, and I'm helping your chemotherapy to work by using all this integrative approach that the mainstream medicine have no clue about it because they're being dictated by the big pharma, sending them the protocols of that specific drug to target that specific enzyme. And definitely what happened is that, first of all, we have genetic variations between all of us. Therefore, so we are different in sensitivity to that drug, right? So 50% will respond, 50% will not respond. And then if they respond, with time, the cancer will mutate, and then they will not be responding to even to that chemotherapy that big pharma is producing. And so we need to be outsmarting that resistance. And we need to come up with protocols that override those resistance, whether changing the delivery mechanism and loading a cyclase nanoparticle cyclodextrin, or switching the drug that's more sensitive, and you can know that by using pharmacogenetics for cancer. So sonodynamic photodynamic therapy also will help. This therapy use non-thermal ultrasound or light to activate the sensitizer molecules like, alpha lipoic, levinic acid, or 5-aminolevinic acid, or methylene blue. Upon activation or indocyanine green, this sensitizer generate reactive oxygen species which oxidize and kill the cancer particular. Even it breaks down the fibrosis as well, particularly in fibrotic and hypoxic zones where conventional therapies fail. So that's one thing you can add. Mebendazole reduce fibrosis and cancer stem cell resistance pathway. Sonodynamic photodynamic therapy also would help in generating free radicals and blowing up those mitochondria and destroy those resistant cancer stem cells embedded in fibrotic extracellular microenvironment, complementing the pharmacologic disruption that we are looking for. Retinoic acid and HDAC inhibitors forcing cancer stem cell differentiation. Retinoic acid, which is vitamin A derivative, and HDAC inhibitors like vorinostat or panobinostat push the cancer stem cells out of their stem-like state into differentiated phenotype. That's very important. We can differentiate them, make them more sensitive, and have this major histocompatibility complex more mature. Plus, those cancer cells, they have, less effective antioxidant machinery, so they are sensitive to the free radicals and easy to induce apoptosis in them. Differentiating cancer cells are less aggressive, more chemosensitive, more visible to the immune because they have major histocompatibility complex that's being mature enough to be attacked by the cytotoxic T cells. Mebendazole blocks self-renewal signaling, Hodge-Hog and Wendt, and retinoic acid HDAC inhibitors force cancer stem cells into differentiation, making them easy to kill with standard therapies or immune cells. And so the thymosin alpha, as we saw, it's an immune modulator. It enhances the immune detection and clearance and polarizes the immune system into Th1 and cytotoxic T cells. Photodynamic therapy helps to generate the free radicals and causing destruction of cancer stem cells and also oxidizing the fibrotic tissue and break them down as well. Retinoic acid and HDA-CI and epigenetically reprogramming and forces the cancer stem cell differentiation and help them to become more vulnerable to your therapies. Anti-angiogenesis via VEGF inhibition, vascular endothelial growth factor inhibition, which is we use Avastin. Everybody knows Avastin, right? We use it for ophthalmic angiopathy due to diabetic neuropathy, diabetic angiopathy, but also we use for cancer because it helps to decrease the overgrowth of blood vessels. Well, those blood vessels are not not normal blood vessels. They are kinky blood vessels. So there are many, but they're kinked. When they're kinked, they will not allow the infiltration of red blood cells and lymphocytes, or they are easily kinked, especially with fibrosis, they will squeeze them. So we need to normalize it, normalize those blood vessels back to normal, to be patent to enough to allow the lymphocyte infiltration with blood cells. And so inhibiting the VEGF, reducing it, reduce the signaling, it's very important, whether using ivermectin, using mebendazole, or using Avastin, or suppress new blood vessel formation and definitely metastatic potential, because when those blood vessels are growing, it helps to spread the cancer as well. Adjunct resveratrol, ACGC, curcumin have synergistic effect and anti-VEGF, VEGF, which is vascular endothelial growth factor. And so adding polyphenols will help. Adding Avastin will help in your management, in addition to mebendazole. That's why, it's all about putting together a cocktail of anti-cancer stem cells, whether peptides, supplement drugs, injectable or oral, and I can help you to create those cocktails. That's what we are. That's something that I'm passionate to do, and that's what I'm doing. Kind of bridging the compounding pharmacy with the doctors here, and plus developing medical devices that will for the unmet medical need. So I'm doing all of that currently. I'm working outside the box. Plus, I'm helping doctors in their clinics as well. So, and I enjoy doing that so that we can upgrade the system. Antifibrotic action of mebendazole mechanism summary. Solid tumor often develop fibrotic tumor microenvironment where activated fibroblasts, which will turn to myofibroblasts, produce excessive collagen and excessive matrix proteins. This fibrotic layer act as physical barrier to immune cells, to red blood cells, even to drugs penetration, and support tumor progression and immune evasion, right? And we need to get rid from those fibroses, and we learn how to do that. Mebendazole interrupt this process by preventing the differentiation of fibroblasts to myofibroblasts and reduce collagen deposition and soften the tumor and enhance the therapeutic axis. That's the reason when you do ultrasound and you're monitoring the shrinking of the cancer, decreasing their mass, also monitor the consistency of the cancer from hyperechoic into echoic into something, and that is a progression. If it's still dense, that's mean you're not yet solving the problem. So you need to turn those cancer mass into similar to the surrounding tissue. That's mean they're not densely with fibrotically dense, which will squeeze out those red blood cells from and lymphocytes and even drugs from infiltrating the cancer. So the fibroblast to myofibroblast differentiation stimulated by transforming growth factor beta 1, fibroblasts convert to alpha SMA positive myofibroblast, and that's one way. Also, to monitor the effects of the treatment, if we can come up with those markers, see them before and after, then we can know whether your drugs is working or not. So myofibroblast secretes collagen type 1 and 3, fibronectin, and this extracellular protein, matrix protein. Mebendazole inhibit transforming growth factor beta 1 Same like losartan and using signaling. Losartan does the same thing. And blocking and also streptokinase or nattokinase will also help in that too. And blocking the alpha SMA expression and myofibroblast transition. Collagen deposition and fibrotic matrix formation. Fibroblasts create dense fibrotic network, preventing the immune cell infiltration, red blood cell infiltration, drug infiltration, right? And this will limit the oxygen and drug from going in. And that's what we need to stop. Because if you don't have oxygen, your chemotherapy will not work, your radiotherapy cannot work, your photodynamic therapy cannot work, and your drugs are not working. So now we know the problem. We know the problem why the cancer oncologists fail. Now you have the tools. Now, as a doctors, now you can solve the problem. And you can explain to the oncologists, the regulatories, the FDA, why you are using those drugs. But again, it's not just mebendazole, it's not just ivermectin, it's all the cocktail of drugs that's anti-fibrotic, which we can create together, and anti-cancer stem cells. So the problem in fibrotic tumor, immune exclusion, chemotherapy resistance, hypoxia, immune checkpoint therapy failure because they cannot get in those antibodies. They're being squeezed out by the fibrosis. And so mebendazole solution losing the extracellular matrix protein, allowing the immune cell to infiltrate, especially the Th1 and cytotoxic T cells, improve drug access to the tumor core, increase the perfusion and reduce the tumor resistance, right? Allowing the red blood cells to go in, the immune cells to go in, your drugs to go in. And then when you get red blood cells in, you get the oxygen in, you prevent, you turn those cancer into hot cancer, right? Boiling, killing the cancer, and reverse the cold tumor microenvironment into inflamed microenvironment, which destroys the cancer. Synergistic adjunct therapies. Of course, as I said, shockwave is one way to break down the fibrosis. Again, we have to create those shockwaves to be specifically breaking those fibrotic, which I'm doing. Those nattokinase will help to break down the extracellular matrix protein, ozone, and reactive oxygen spares therapy. That's good to bypass the squeezing out the red blood cells carrying the oxygen in. You can dissolve those oxygen to the plasma, get red oxygen, get the oxygen into the tumor, and all has synergistic adjunct here. Dosage and customized based on RGC. That I be what I do is that I ask you all your cancer patients. You send their blood sample to the RGC, and they will come up with a list of drugs that you need. And then you also need to do all the imaging, knowing exactly the status, CT scan, PET scan. You also need to check the hepatic and renal function, right? And based on the RGC, you can come up with the cocktail of the drug and the dosing and make sure you deliver the drugs in the right way, whether loading inside cyclodextrin through the compounding pharmacy or by loading inside place nanoparticle. And I can help you all the way. Just let me know, reach out to me. I can help you to develop those cocktails, to load them inside cyclodextrin, to help you to load them inside platelet nanoparticles. So the drug dosing and formulation delivery system, I can help you with that and all the dosing, all that stuff for all the drugs. But for ivermectin, 12 to 36 milligram a day or 200 to 400 microgram per kg, 2 to 3 weeks. And you can load them inside cyclodextrin, will be great, orally or IV. We can create ivermectin IV for you as well. Mebendazole, 100 milligram BID or TID for 3 to 6 months and cyclical, and you can load them inside cyclodextrin as well. Again, I like to combine a lot of things together. You can end up creating a cocktail of drugs with redox modulators, alpha lipoic acid, vitamin C, melatonin. All of this will help in your managing your cancer, right? To enhance the mitochondria, to blow up those ticking bombs of mitochondria inside the cancer, and then enhance the immune system using thymosin alpha, 1.6 milligrams subcutaneously, or the Viscom album, stimulate fever range immune activation. That's another thing. Or low dose naltrexone, which will have the Th17. That's another thing, and then have the Tregs that will boost endogenous opioid and immune function. Definitely, and have the Th17, allowing the immune system to be polarized to Th1 and kill the cancer. Again, metabolic disruptors, I will use them, metformin, berberine, which is AMPK inhibitors, which inhibit the mTOR and the glucose uptake. That's a good thing. So you can block the Warburg phenomena. Ketogenic diet and fasting was another way to help to manage the cancer. Short-term fasting, that's a good thing, right? Which will help to induce autophagy by activating the AMPK. Antifibrotic tool, shock waves, which you need to have specific shock wave with specifications that breaks down the fibrosis. Nattokinase loaded with cyclodextrin will help to break down this extracellular um, protein, matrix protein. Photodynamic therapy, target the fibrotic tumor zones with light and sound, generate reactive oxygen species, and also it helps to break down the fibrosis. Again, you need to monitor the effects of the treatment using your imaging, ultrasound, PET scan, and you need to come up with all the markers, and you need to know how those drugs helps in reducing those markers. We can do the circulating tumor cells count or cancer stem cells count with RGC lab, and you can come up with the Wnt and Hodgkin markers, and then when you're doing the treatment, you can see a drop in those markers. And you can do also immune subtypes, lymphocyte mapping, cytokine profile will help you as well. Circulating tumor DNA to a real-time tracking of tumor burden and mutation evolution. You can do that through RGC lab. And also you can see the ratio of the oxidized and reduced glutathione, especially when the patient is hammered with chemotherapy or radiotherapy, and you want to help to start healing those patients. You may need to know the oxidative stress markers and then help to monetize it and help to give them enough of vitamins and antioxidants to heal and support the immune system again. And you can measure the oxidative stress status of the patient using oxidized those nucleic acids in the urine, for example. MRI, PET scan will be a good thing to monitor, especially PET scan. I like PET scan more than any other things, and then also ultrasound to see the consistency of the tumor. And then if you want to check the whole general health of the patient and how much damage to the general health of the patient, use endothelial function and autonomic nervous system. And then you need to give them all the treatment that helps to normalize it, because you need to optimize the health of the patient so that they can continue to fight the cancer, especially after they've been debilitated by chemotherapy and radiotherapy and immunotherapy. And so addressing the clinical gap, the combination of ivermectin, mebendazole under CDP-MCS guidelines form a safe, affordable, and mechanistically precise foundation for reversing aggressive and recurrent cancer. And I think we talked about all this in the previous slides, the importance of getting rid from the cancer stem cells and from the fibrotic barrier and from shifting the immune system into Th1 by giving anti-CDL1, anti-CTL4, anti-PD-L1, and giving them thymosin alpha, right? And by blocking the transforming growth factor beta 1 and breaking down the fibrosis using shockwave or directing or by suppressing and inhibiting those cancer stem cell signaling, which is the WNT and Hodgkin inhibition using ivermectin and mebendazole. So group by, if you want to know about list of drugs, again, we as doctors, say, mebendazole, ivermectin, you cannot use it anymore. What's the alternative? Okay, the alternative is easy. As doctors, we can just find the drugs that has similar mechanism of action. And albendazole, if you don't have mebendazole, you can use albendazole, you can use fenbendazole, you can use thiabendazole. You can, if they don't have all of that, the FDA stop all of that. You can use the paclitaxel low dose, right? You can use vincristine, vinblastin. All of this can be alternative to mebendazole. Okay, what about the Wnt and beta-catenin and Hodgkin pathway inhibitors if I don't have ivermectin? I can use salinomycin, which will be alternative. I can use nicosamide, which also has antifibrotic effect as well. I can use disulfiram.
I can use etraconazole, which is antifungal. I can use pyrivinum PAMOUT, which will target the Wnt signaling and mitochondrial metabolism. So I have alternative, and I'll create a cocktail of all of this in one drug, and I can help you to do that. Let's say, what about mTOR, an AMPK, redox modulator, metformin? I don't have metformin. I can use fenformin. I'll use them both, or you can use rapamycin, or I can use them all and put them in a cocktail. What about natural compounds that helps to kill the cancer stem cells? Curcumin would be one. It will help in Wnt pathway. Resveratrol will help the Hodgehog and Wnt pathway. Sulforafan also as well will target the cancer stem cells and modulate the histone acetylation. Or I can use the EGCG, which will help the cancer cell proliferation and the transforming growth factor beta inducers. So there is alternative, or we can create a cocktail of drugs and supplements and peptides against cancer and against cancer-associated fibrosis. Antifibrotic drugs or supplements. You can use quercetrine to suppress the transforming growth factor beta. You can use berberine to modulate the Wnt and mTOR and inhibit the fibrosis. You can use honocuol, which will induce apoptosis in cancer stem cells and suppress the fibroblast activation. So we can use all those supplements to put them together in a cocktail, and I can help you to do that and give it to the patient. Plus, giving N-acetylcysteine and alpha lipoic acid and methylene blue, all of this will help to enhance and change the tumor microenvironment to become a hostile environment. In addition to peptides, you can use thymosin alpha to enhance the immune recognition and target the cancer stem cells. You can use LL37, which is antimicrobial peptide shown to modulate the tumor. We can use the proline-rich peptide, which has anti-cancer stem cells. So we can use peptides, drugs, supplements, putting together a cocktail that will inhibit the cancer-associated fibrosis, that will activate the AMPK, inhibit the mTOR, that will help to inhibit the Wnt and Hodgehog signal. Antifibrotic peptides, buzerline, the triptyroline, which is GnRH analogs that downregulate fibroblast activation and hormone-sensitive tumor. Relaxin peptide, antifibrotic via MMP activation and collagen degradation. Angiotensin 1,7, reduce transforming growth factor signaling and fibrosis. That's another one, angiotensin 1,7, right? And so we can use peptides, drugs, supplements, put them all together in a cocktail and target those challenges, those tricks of cancers, whether it is fibrosis, whether it is cancer stem cells, growth factor antagonist and immune peptides, anti-transforming growth factor peptides, blocks the fibrotic signaling. And the CD47 and SIRP alpha blocking peptides enhance the immune clearance of the, so I can use these peptides, immunopeptides, in our cocktail to enhance the immune clearance of cancer stem cells. So summary, both the mebendazole and ivermectin act as via multimodal mechanism to disrupt the cancer stem cells niche, which is tubulin and Wnt, beta, catenin, and STAT3, induce redox imbalance and disrupt the fibrosis via transforming growth factor beta. Other agents listed in complement or amplify these effects, which we can use it together. A therapeutic cocktail from these three may be synergistically layered in chronic disease prevention management centers protocols for tumor reversal, stem cell exhaustion, and fibrotic microenvironment and reprogramming. Again, we can load drugs inside nanomedicine. We can load all those formulation into cyclodextrin or platelet nanoparticles, and I can help you to do that. We can load all those photodynamic therapy or sonodynamic agents into cyclodextrin and platelet nanoparticles, and I can help you to do that. And I think the conclusion is to use those drugs. Ivermectin and mebendazole represent a new generation for repurposed pharmaceuticals that function beyond their anti-parasitic origin. So the problem with big pharma, they don't believe or they don't have in their mind that drugs can work as anti-inflammatory and anti-cancer or antibiotic and anti-cancer. If it's proven by antibiotics, that's it. Like ivermectin, oh, it's antiparasite. How are you using it for cancer? They don't have that mindset that those drugs can work in double actions. And many drugs like tetracycline works as anti-inflammatory plus it's antibiotics. Ivermectin works as anti-inflammatory, it's antibiotic plus it's anti-cancer. They don't have that mindset of opening to understand that drugs can work and have multi-mechanism. So they have function beyond antiparasitic. Within the CDP-MCS protocol, they are key agents in disrupting cancer stem cells, signaling, inducing redox-mediated apoptosis, and remodeling fibrotic barriers, coupled with real-time RGC testing, which is very important, immune modulation, redox balancing, and personalized delivery system using cyclodextrin or platelet nanoparticle. These agents embodied the shift toward precision system on an approach that does not just attack the tumor, but reprograms the internal environment to support the long-term remission. And I think I'm done, and all this are the references in case you wanted. And if you have any questions, let me know. And this is the CME for 2 hours, and I think I spent 2 hours already.
I do have a few questions.
Go ahead. We have CME for 2 hours for this. Yes, go ahead.
So, and this is on the nursing aspect, educating patients in the pharmacy. Ivermectin and fenbendazole. When you prescribe for cancer and they're taking both of them, we have been telling them to take perhaps the ivermectin. We do, let's say your dose is going to be 46 milligrams daily, but we titrate them. Week 1, they take 1 capsule for 7 days. If they tolerate, then week 2, they take 2, working up to their dose of 4 times a day. And then we do the fenbendazole, 225 milligram, 3 days on, 4 days off. Would it be better to have them take perhaps ivermectin in the morning, fenbendazole in the evening? We're not instructing them to take them at the same time.
The reality is that we don't have much of extensive studies about the dosage.
Mhm.
And we just have some data from the experiments that has been used and been successfully treating it, which I think I put it together in the presentation. So as much as you are creative there, as much as you don't go, as long as you don't go beyond the toxic dose, and you're using what's being approved by FDA for antiparasites, then you are in a good shape because
Okay.
the safety is being passed. So repurposing drugs, they already passed the safety, and they know the toxic dose, and they know the therapeutic dose. And as long as you are within the window of therapeutic dose, you can be creative in dosing and giving it to the patient. I think what you're doing, it's good, and you continue with it. With data from all the doctors, then they may be perfecting the dosage. So we don't have yet, the final recommendation about how much dosage you do. But the idea about using low dose first to see the tolerance of the patient and then go up to get into the highest therapeutic dose, that is the option that we have currently. So I don't have much of take there, to tell you this is the perfect dose, because in order to do that, you really need to have a lot of patients and a lot of data, which we don't have it yet because it's not yet in the mainstream medicine. Only few of integrative doctors are creative, thinking outside the box. They start using it, and they are reporting good results, and we are copying it. But I think in the future we will have that complete, solid protocols for everybody to follow.
Okay. And then I just had one other question. What are your thoughts on a postbiotic, a fermented yeast? It's Saccharomyces cerevisiae, I believe. to promote gut health and improve immunity for cancer patients.
So probiotic and prebiotic, anything that helps to enhance the butyric acid will definitely help to decrease the exhaust of the immune system. Because what we need is to balance the immune system in the body so that we don't exhaust them and we have enough of immune system is focusing on destroying the cancer. So if you have inflammatory bowel problems of leaky gut and inflammation in the gut, that's called immune exhaustion. And then like polarizing the immune system into Th17 too much in the gut, that takes your immune system power from killing the cancer into busy dealing into your gut. So tackling all the autoimmune diseases of the patient, all the leaky gut, any unnecessary inflammation in the body, including allergies. You need to really optimize the health as much as you can and manage any unnecessary inflammation so that your immune system is now focusing on killing the cancer instead of losing at the battle or busy destroying your self-antigens or unnecessary inflammations like gut inflammation or leaky gut syndrome or others. So anything that helps to optimize the health, not just inflammation, but also metabolically, optimizing your sex hormones, it's very critical as well. So that you reduce the amount of cortisone that suppress the immune system, suppressing the Th1. So optimizing sex hormone, optimizing all the metabolic pathways in your body, it does help to empower your immune system to kill the cancer. That's the reason anti-PD-L1, anti-CTLA4, and all those immune therapy do work in killing the cancer, which is good. But at the same time, it also induces colitis and unnecessary inflammation against your self-antigen because it helps to even take your immune tolerance against your self-antigen out. And that causes exhaustion of the immune system. That's the reason we have a problem with immunotherapy. There is some problems of, because it triggers colitis and inflammation unnecessary and exhausting the immune system. And that's the reason we load those, the better is to load those drugs or antibodies into platelets nanoparticle to concentrate them into the cancer instead of going everywhere. So targeted therapy is very critical for immune therapy to work better. And a company is called Cellular Therapeutic. They are working on loading drugs, supplement, antibodies, chemotherapy inside platelets nanoparticle. It's a big pharma. It takes them 10 to 20 years to be approved. But then all the drugs will be now delivered by platelets nanoparticle in the future or by the exosomes. Now, which is better, platelets nanoparticles or exosomes? Umbilical exosomes, the problem with anything that's not autologous, something that's coming from outside, the macrophage can, and the lungs and the liver can intercept them. So if you load umbilical exosomes with chemotherapy, the problem is that if you have brain cancer, it will be intercepted by the liver macrophages and the lung macrophages. Same like any synthetic nanoparticles. So platelets nanoparticles that is autologous coming from the patient works as a torsion. We don't have that problem of intercepting by macrophages of the lung and liver, so they get more concentrated in the cancer. So I favor platelets nanoparticle over exosomes for that reason. And plus, I favor platelets nanoparticle over synthetic nanoparticles because of that reason as well. And I can help you to get that going and get you the training to load the drugs inside platelets nanoparticle. I already trained 10 doctors, but I need more doctors to say yes. It's not that much. It says 10K, you get the equipments, you get the training, and hey, you become better than anybody else in managing any chronic diseases, whether it's cancer or regenerative or infection, because now you can even any resistance to those antibiotics, you can bypass it by platelets nanoparticles. And also you can deliver the drugs into the pathology, even for regenerative medicine, when you do those injections of platelets nanoparticle loaded with thymosin beta or BBC 157. BBC 157, I mean, Those are very good peptides. I use it for myself. I fall on my back from the second floor on a concrete, and I break the granite on the concrete. And I end up traveling to Germany, and I got those injections of PBC 157 and ketorolac, and my back is okay. I mean, I don't have any fracture or anything like that, but it heals like crazy. So I believe in those peptides do signal healing and regeneration of the endogenous stem cells of the body. And loading inside place nanoparticle will be even better, especially for all the injectables. Any other questions? Dr. Kamal, do you have any questions? We still have 11 here, people.
No.
Okay, good. So tomorrow, Michael Emmanuel, if you can load the drugs inside cyclodextrin, you are compounding pharmacy. You can go ahead and introduce yourself.
Hi, this is
But
Mike.
let me do something here. Let me close the recording. Can you close the recording?
Sure.
आपने recording बंद कर